Okay, so we want to solve these three triangles to see the different scenarios. So these are going to each come up with the, one solution, two solution, and no solutions. We're going to go through this together so you can see what I said my method is, and that is basically pretending as if there's going to be a solution, or assuming there is going to be one. So if I start over here with the triangle on the left. Okay, the nice thing about the ambiguous case is it only gives you one thing to solve for first. So since I have angle A, side A, and side B, I have to solve for angle B first. So I'm going to say the sine of B over 14.3 equals the sine of 17 over 5.8. Multiply by 14.3, so I have the sine of B equals 14.3 sine of 17 over 5.8. Type this into my calculator and I get sine of B is approximately 0.721. Okay, so right here I know for sure I'm going to have at least one solution. How do I know that? Because my next step is to do the inverse of sine, and because this number is between -1 and 1, I know that that is going to exist. So if I do sine inverse, so B is sine inverse of 0.721, and that is 46.124 degrees. Okay, so now from here I can continue on with this solution, but I'm also going to start my second solution simultaneously. So as I'm working this, the next thing I'm actually going to do is I'm going to find what I'm going to call B prime. So I'm going to take these and I'm going to move these over here so we can see the organization. So B prime is the other angle B, and that's going to be the supplement of the first angle B. So here's the thought process that I'm going with. Since I know for sure I have one solution at this point, I'm going to assume that I have two solutions, and I'm going to find out relatively quickly whether that is true or not. So I know that this other B angle is going to exist. So 180 minus 46.124, and that's going to come out to be 133.876. Okay, so now I have two parallel solutions. So these are separated. On the left is one triangle, on the right is another triangle. Both of them have side A as 5.8 and angle A as 17 degrees, and they have two different angle B's. Now I need to find angle C for each one. So I know here angle C is going to be 180 minus 46.124 minus 17, which comes out to be 116.876 degrees. On the other side here, C prime is going to be 180 minus 133.876 minus 17. This comes out to be 29.124. So since I was able to get all three angles for both triangles, I know that two solutions do exist. When I was solving for this C prime in this case, had I gotten a negative number, then I would have known that the second solution is not actually a solution. Now all I have left to do for both solutions is to find side C. I'm going to use the law of sines, little c over sine of 116.876 equals, and again, use the givens whenever you can, so 5.8 over the sine of 17. So I know little c over here is going to be 17.695. Little c over here is going to be little c prime over sine of 29.124, and this equals 5.8 over sine of 17. That's a 4. That's a 9. So when I solve for little c prime, I get 9.655. Okay, so this was an example of two solutions. So now let's look at the next one. So up here, I'm going to bring this down because this is the one we're solving. Okay, so we've got an angle A is 76 degrees, side A is 18, side B is 20. So again, I'm going to just assume that there's at least one solution. So the only thing I can find is angle B. So I can do the sine of B over 20 equals the sine of 76 over 18. Solve this, I end up with the sine of B is 20 sine 76 over 18, and when I type that into my calculator, I get the sine of B is 1.078. So I don't even have to do the inverse now. I know that this is outside of my domain of the sine inverse function. Therefore, I'm done. This is going to be no solution. If you don't believe me, do sine inverse of 1.078. But see, so that's not a ton of work to figure out relatively quickly that you get no solution. Alright, and then just to show you the last one, spoiler alert, it's going to give you one solution, but I want to show you how, if you follow my method, you can find that relatively quickly also. So we'll start the same way, find angle B. So I know the sine of B over 10 equals the sine of 58 over 20. If I multiply by 10, I'm going to get the sine of B equals 0.424. So since this is within my domain of the inverse function, I know I'm going to have at least one solution. I do the inverse, B equals 25.089. Okay, so since I have a B, I'm going to assume that I have a second solution. So B prime is 180 minus 25.089. And now this is always going to work. So if you get a B, you're always going to get a B prime. So B prime equals 159.911. And so now I'm going to go ahead and find angle C. So C is 180 minus 58 minus 25.089. So angle C is 96.911. Angle C prime, here we should be able to see relatively quickly, is not going to work. Because I'm going to do 180 minus 58 minus 159.911. That's going to be a negative number, so this solution does not work. However, I still have one solution. So now I can go ahead and find little c over here. So little c over the sine of 96.911 equals, this wrote there, 20 over the sine of 58. And so if I solve for little c, I end up with little c is 23.412. Okay, so that was an example of one solution. So it's up to you whether you want to use the books method or whether you want to use what I showed you. It doesn't matter as long as you figure out the right answers. So we want to make sure we understand our area formula, make sure you know the law of sines, know when the ambiguous case is possibly going to come up. Again, this version of the law of sines I prefer for solving for a side. This I prefer for solving for an angle. But in the grand scheme of things, it doesn't matter, as long as you get the right answer.